We're going to continue with the book Dive into Systems, Chapter 3, Section 1, completing the last sort of part of this section where we look at how to use GDB on a program that crashes. Looking at the second example, we're going to go ahead and grab the code. We're going to make this file, so we're going to call this, what did they call it? Not that we have to use the same name, but it's probably good if I do. So segfolter.c, put the code here. Now we're gonna make a command, segfolter. It will use segfolter, and it issues the command gcc segfolter.c to object file segfolter. Now, in fact, somewhat predictably, we'd like to go ahead and add segfolter to the clean command, but before we do, let's notice that we've also been producing this a.out. So let's go ahead and remove a.out, and that just cleans basically everything in the directory. And we'll also clean out segfolter, and let's go ahead and save that. Then let's say make clean. So you see every executable has now been eliminated, except that it tried to clean segfolter but couldn't find it. That's fine. But now let's make segfolter. Great, it builds just fine. So whatever causes this program to crash, it must be runtime, not compile time, because it compiled just fine. So let's go ahead and run segfolter./segfolter. And segmentation fault core dumped, which is a fairly typical error response. Like C errors tell you so little that it does make GDB almost essential, because you just like learn nothing from the standard sorts of error printing that C comes with. So because we see that it throws an error and we don't understand why, maybe we'll just go ahead and jump into GCC, right? We're going to compile with -g flag, segfolter.c, and we can go ahead and compile to a binary, or I'm going to not do that just so that it's called a.out, and then if we need to, we can clean off a.out. So yeah, I think I'm just going to do that. Now it's called a.out, and then I can call GDB on a.out. And let's just jump into it. Let's run, no breakpoints so far. And because it crashes, right? Like we know that it crashes, it gives this like segmentation fault thing. Then I didn't need to like set a breakpoint. If the program were, successful or whatever, you might need a breakpoint to be able to pause the program and investigate the values of variables. But because this thing crashes, then it'll basically sort of just go straight to the moment of the crash and basically in this way kind of stop it from crashing so that you can see everything that's going on right at the moment of the crash. And that's what's happening now. We could go ahead and see what happened to get here? Are we in the main function, or are we, is there something else in the stack? Well, a call to where is going to tell us that, yep, it crashed in the middle of executing initfunc, right? Because we are in, right, like at the moment of the crash, the top of the stack, the execution stack was initfunc. So we know that, right, somehow at that point, that's where the crash occurred. We could list in order to see what initfunc is, right? So it's going to tell us that here's the declaration of initfunc. Here's the first few lines of initfunc. In fact, it's so short that we can just see everything with this one call to list. And so what does it do? Well, it goes from 1 to len inclusive. Now that's possibly the source of the bug if len is the length of the array, which you would imagine that it is. So there we're going to be accessing some index in the array, which does not exist. So that's a real risk. So that might be the whole error right there. But we could also, sort of interrogate the various values of various parameters like what was the parameter value at the moment of the crash? Well, we could print I. That's not a parameter value, but we could still print it. Should be within the current context. So if we print I is equal to 1. Doesn't sound bad, seems fine. If we then ask it to print array at I, cannot access address at this, and so then, why would we not be able to access this index? Well, what happens if we print array? And that's pretty telling. This is 0 by 0. The base address is 0, which is to say that this array is really pointing, its pointer is the null pointer. So why is it the null pointer? Well, if we wanted to, we could, go to the main frame, frame 1 at this point in the execution stack. So we could say frame 1, and now we're in main. What we're interested in is like, how did this array, which, looking at this, you can see that the array was passed in as an argument, so it must have been passed in as null. So why was it passed in as null? Let's go ahead and list what's in main. And you can see that what happened here is that it was initialized to null, that never changed, and then it was passed in here. So that's the source, that's at least one source of a bug. So it was, right, we're passing in the null pointer, and then by the time we get to using the array, it's pointing to null, and that's going to cause a segmentation error. We could fix that and then see if the program runs. Presumably, actually, let's just go ahead and say, like, okay, so it passed in for len the value 100. If we made this, right, if we malloped the array and gave it space for 101 integers, then, saying that the len is 100 would not give rise to an error, but that's probably not a good idea. Probably, like, just as good practice, we should generally have I go from 0 to strictly less than n. That would probably be the better fix there. But I guess that's it. We now see how to use GDB on a program that crashes. If we wanted to, we could have set breakpoints that paused the function before reaching the crash. But it's nice to know that if it does crashes, you can just like jump right in, call run with no breakpoints, and you can still see what was going on right at the moment before the crash occurred.